We're going to be talking about the mole. Are we talking about this mole? Nope. Talking about this mole? Nope. Talking about this mole? Yeah, you got it. A couple things you need to know that mole can be abbreviated MOL. I know that's a great shortening, isn't it? We can never have M, capital M, or lowercase m. That the capital M stands for molarity, which we're going to use starting second semester, and lowercase m means meters, so we can't use those. But we can use MOLE or MOL. A couple things that you had to keep in mind as we're going along, and a little bit of this is review. We talked about this number right here is called molar mass. That's how many grams there are in 1 mole of copper atoms. So we're going to be using that a lot as we're going through this part of the unit. So if we look at copper again, this is how many grams there are in 1 mole. So 63.55 grams of copper in 1 mole of copper, or 1 mole of copper, 63.55 grams. Both of these will be used in equations, and we need to realize that we can flip them either way to make our equations work. So starting out on the top of the 30s, 6.02 times 10 to the 23rd has 3 significant digits. So in our problems, we always have to look at 6.02 times 10 to the 23rd as having 3 significant digits. There's a few questions that we're going to go through before we really get into the math. It says H2O is a molecule or an atom. That's a molecule. A molecule is 2 or more atoms stuck together. H2O is made up of 2 blank of H and 1 blank atom of oxygen. So that's 2 atoms. Kind of left the cat out of the bag there. 2 atoms of hydrogen and 1 atom of oxygen. In 1 mole of water molecules, there would be 2 blank of hydrogen atoms and 1 blank of oxygen atoms. Well, if there's 1 mole of H2Os, for every 1 mole of H2Os, there would be 2 moles of H. So I'm using the mole shortened version. I'm using the mole longer version. Either are fine in either blank. We're going to do some factor label problems. This is on your cover, I believe, but it's right here for sure. It's going to tell us how to go through the steps for solving these problems. It says step 1, start with what you're given. Step 2, place a multiplication sign. Step 3, place a division bar. And step 4, whatever the label is on top of the previous step goes on the bottom of the next step. So we'll apply that to our next set of problems. So if we look here, we have label A on top. Label A ends up being on the bottom. Label B is right there. Label B is right there. So whatever's on top goes on the bottom of the next step. So what's the general rule? Well, I just kind of said it. Whatever's on top of the previous step goes on the bottom of the next step. Top, bottom. Okay, all those labels cancel out, and at the end you're left with your label of C, which is your answer label. What's wrong with this step? Go ahead, pause the video, see if you can figure it out. Well, what's wrong with this step is moles of lithium cancel out with moles of lithium. And up here we have grams per mole lithium. That means our label should be grams per mole lithium. Well, that doesn't make any sense because it wants to figure out how many actual grams we have. So right here, we're never going to have grams per mole as a top or a bottom. We can have grams of lithium over moles of lithium. You can have moles of lithium over grams of lithium, but you can never have grams per mole of lithium on the top or grams per mole of lithium on the bottom, because grams over moles, that is this right here. Couple things about this mole map. It's on your cover. It's on your sheet here, but on your cover, we got the bridges label. So we got Gram Island. Anytime we start with grams, that's where we're going to start. Anytime we start with moles, this is where we're going to start. Anytime we start with atoms and molecules, this is where we're going to start. We'll talk about that miscellaneous as time goes on. These islands are out in the deepest, most dangerous ocean that you'd ever seen, and you cannot get from one island to the next by airplane. Pterodactyls will get you. You can't take a boat. The sharks will get you. Can't get to any island except for these bridges that are right here. So you got to go across a bridge to get from one island to the next. These bridges have names. Anytime we go between mole island and atom and molecule island, you're going to use 6.02 times 10 to the 23rd over 1 mole. Or I could flip this and I can have 1 mole on top and 6.02 times 10 to the 23rd on the bottom. Anytime you go from Graham Island to Mole Island or Mole Island to Graham Island, you're going to look at the periodic table. You're going to find the molar mass of the compound or the atoms that you're dealing with, and you're going to find out how many grams per mole that particular item is. Every time you go across a bridge in a problem, it is a multiplication sign. So if I go across a bridge, if I go from here to here, I'm going to have 1 multiplication sign in my problem. If I go from here to here to here, I'm going to have 1 multiplication sign there and 1 multiplication sign there. So it kind of sets up my problem for me. So here we go. Here's our first problem. I have this many grams of F2. It says that F2 is a diatomic gas, so that's why it's F2. It wants to know how many moles that would be. So I'm starting off with grams. I'm going to go to Mole Island. I'm going to go across this bridge right here. And since there's only 1 bridge involved, it's going to involve 1 multiplication sign. Going up a little bit higher on your sheet, up to D, it says we start with what we're given. So we start with 1, 2, 3, 4, 5.1 G F2. I go back up to D, it says place a multiplication sign. Step 3 for D says place a division bar. Step 4 says whatever the label is on top here goes on the bottom of the next step. So grams of F2. That's got to become a reflex. You just pop all that information in there. You don't really give it much thought whatsoever. I'm on Graham Island. If I'm on Graham Island, the only place I can go is to Mole Island. So I can go from grams to moles by crossing a bridge. So I can go to moles of F2. I can't go to anything else. The bridge only connects Graham Island to Mole Island. The bridges themselves are the division bar. So this bridge right here is this division bar right here. So that is the bridge. That bridge, if we look on your cover, is called grams per mole bridge, which means we go to the periodic table and we go get a molar mass. The molar mass for fluorine is 19.00 grams per mole. So if you have F2 fluorine gas, that's 38.00 grams per 1 mole. So grams per mole can be written that way. So the 38.00 is always going to go with the grams. Sometimes the grams are on top, sometimes the grams are on the bottom. The 1 is always going to go with the mole. I solve that. Those grams of F2 cancel out with those grams of F2. The numbers don't cancel out, but the labels do. I do the math, and I get 324.871 on my calculator. Let's go look at some sig figs. So I go to this first number, and I have 6 sig figs. I go to 38.00, I have 4 sig figs. This 1 is infinite sig figs. That's how many grams there are in exactly 1 sig fig. So we're never going to count this 1 as just being 1 sig fig. So if I look at this and I follow the rule for multiplication, my answer could only have 4 significant digits in it. So my answer would be 324.9. My label that I'm left with at the end is moles of F2, mole F2, and that is my answer. If you want to try this problem before you play it, go right ahead. So in this problem, we're going to go from moles of aluminum to atoms. So the problem's a little different. It only goes across 1 bridge, which means 1 multiplication sign. I go up to D above. It says you start with what you're given, 23.89 mole aluminum. Multiplication sign, division bar, whatever this label is, it goes on the bottom of the next step, moles of aluminum. All of that was from D up above. I just followed that. Those steps don't change. Again, it needs to be reflex. I'm on Mole Island. I could go over here to grams, but it's not asking me to go to grams. It's asking me to go to atoms, so I'm going to go that way. And I can go from mole island to atom island. So atoms, AL. I'm only going to have one bridge that I'm crossing, so I'm done. I have my one multiplication sign right there because I want to cross my one bridge. This bridge, if you look on your cover, 6.02 times 10 to the 23rd of something over 1 mole. So that's 6.02 times 10 to the 23rd atoms is 1 mole. In some problems, the 1 mole is on top, and the 6.02 times 10 to the 23rd are on the bottom. Just depends on which way you are going. I solve this problem, and I get 1.43817 times 10 to the 25th. Well, let's go look at some sig figs. Here I have 4 sig figs. Here I have 3 sig figs. Here I have infinite sig figs, so my answer should only have 3. So this one would be 1.44 times 10 to the 25th. This is my ending label. Moles of aluminum cancel out with moles of aluminum. So that's going to be atoms, aluminum. That's how you solve those problems. The rest is homework. There are some answers on the very bottom to see if you are doing these problems correctly.